Good morning, everyone. I'm Kirtika from Francis Xavier Engineering College, Department of ECE 2020 batch. I welcome everyone for today's STTP, Lot and Industry 4.0. And now I like to call upon Newlin Jennifer for prayer. Over to Newlin Jennifer.
Let's bow our heads for prayer. Dear loving and most gracious Heavenly Father, we thank you and praise you for this wonderful moment, Lord. Thank you for all the countless blessings you have given us, Lord, as we're gathered together in your presence for this training program, Lord. Before we start this program, as your word says, for wisdom will come into your heart and knowledge will be pleasant to your soul. May you extend your divine wisdom to our resource person to impart God's given knowledge to all of us. May he be blessed as he continues to bring his expertise to people who need them. Bless our HOD ma'am, organizers and coordinators, and also the students. Protect all the people as the apple of your eye, Jesus. We commit ourselves to you, Lord. We ask all this in the glorious name of Jesus. Amen.
Now I would like to invite my friend Preeti to give introduction about our chief guest. Over to Preeti.
Hi everybody, I am Preeti from Francis Xavier Engineering College of 2020 batch from EC department. I am profusely elated to take an opportunity to introduce our today's speaker, Ajay Kumar Godara. He is a founder and director of Enovate Skills, a NITTR Chandigarh startup initiative. He is innovator and mentor of change, NITI Government of India. His expertise in area of robotics, Internet of Things, and AI. He has developed many innovative products and having patents in renewable energy areas. He has developed more than 100 expert talks in national and international faculty development programs voice contact mode and ICT based. He has trained more than 20,000 students. His work ethic speaks for itself, sir. Over to Ajay, sir.
A very good morning to all the participants over here. So in today's session, we are going to discuss about IoT and IoT applications for designing any new innovative project or product. So when we talk about any product, so first of all, we have to understand about their requirement of the product. And after that, we are moving towards the technology that we are going to use it on that particular product. So now we are fighting in that COVID-19. So how you can build some innovative product to fight that COVID-19? That is current scope that I'm just talking about. So similar way, there are many scope, many areas over there we can work and we can build some interesting project and product. So let's get started. First of all, I'm going to discuss about introduction about IoT and Industry 4.0. Then after that, I will discuss that hands-on exposure, that how you can build innovative product at your home without having any kind of hardware. So let's get started. So first of all, we are going to discuss importance of IoT and where that IoT is being implemented for building any kind of product or industrial applications. So first of all, we are going to discuss about major industrial revolution that happened in the past, and with the help of that past industrial revolution, a lot of improvement in the society came, and lot of improvement and as well as development we can call it. So these are three major industrial revolutions that happened in the past, and first one is hydropower and fossil fuel, and the second one is electrical energy and mass production. That mass production concept came from the Henry Ford, and with that small concept, that very big revolution came in the market. So earlier it was very difficult to access like car and four wheelers kind of vehicles, because that manufacturing speed was very much slow. But as that mass production concept came, so that the production of machines, production of equipment and devices become very fast. So similar way, there is a third industrial revolution that was in the past, that is telecommunication and PLC. So when we talk about telecommunication, there is many revolution happened in the past. So one of the major industrial revolution, that is telecommunications. So when we talk about telecommunications, so you can just visualize like earlier in 10 years before. So that you can visualize that what was the call rate over there and how much internet speed over there. But now in these days we are living in the 4G era, and over there the internet speed is too much good, and now we are going to enter in a 5G also. So that you can see that how much impact of telecommunication that is going on, and that was third industrial revolutions. But now we are living in the era of fourth industrial revolutions, that is industry 4.0. So might be you have heard about industry 4.0. So industry 4.0 mean fourth industrial revolutions that is going on in the industry. So why I'm going to talk about IoT over here, because industry 4.0 is a complete industrial revolution that is going on in the industries. But the major part is over here that when we talk about IoT, IoT is one of the component of industry 4.0. So what is the meaning of that industry 4.0? So the concept industry 4.0 came from the Germany, and it's mean that organizing your factory, making your factory smart, and so that you can serve your customer in a better way, and your production will be flexible and resources should be optimized properly. So these are key principal factor of industry 4.0. So first one is factory become digital and flexible. That is very much important. I will share with you with an example that how it is very much important. Then second is simulation tool and powerful data processing. Third one is a efficient factory regarding energy and resources. So when we talk about first major principle over here, that how you can make your factory digital and flexible. Reason behind that, in today's scenarios customer demand is very much flexible. So if you are going to make any product for current situation, might be that product cannot survive more than 1 month or more than 3 months. So that life cycle of that product we have to select wisely, and accordingly we have to make our factory flexible. That is their demand of that particular product will get modified or gets changed, so that you can modify your factory. So one of the example over here, that is 3G and 4G that I'm going to share with you. That in a 3G earlier, that Airtel and Idea and Vodafone, all these companies were pioneer at the time. But as the 4G came, so Reliance directly came bring Geo in a 4G, and after that you can just see what happened with all other players. So because all other companies were not able to change their factory and their system into a new technology era, because there or all earlier investment is being done on particular 3G technology. So if they have to shift in 4G segment and 4G technology, they have to do huge amount of investment in that particular domain. So when we are going to enter in any segment or any industry over there, we have to understand that flexibility, that if there is any new technology is coming, so that can be implemented or can be integrated over there in an existing system without doing any kind of further investment. So that is very much important. So take an example of mobile phone. So in every 3 months, a new model of that particular mobile phone is coming. Like any company, you can take it. If the company that is not bringing new model, so they are just going to wipe out from the market. Just take an example of Nokia, and similar way you can take any other example also, like Micromax and all that. So that is very much important to understand that need of flexibility in any factory. So second part is over here, that is simulation tool and powerful data processing. Now in these days the computer is more powerful than earlier. So with the help of that you can do simulations. So that simulation will give you 99.9% accurate result. With the help of that you can do forecast, and as well as you can start manufacturing of your product based on that simulations. That is very much important. So earlier when we talk about three-wheeler segment or four-wheeler segment, so their crash testing is being done practically by implementing or by testing that particular vehicles. But now in these days 90% of the testing is being done on the simulations. So with the help of that they can save a lot of cost, a lot of money over there. So similar way you can make your factory efficient in terms of energy, in terms of resources. That is very much important over here. So now when we talk about industry 4.0, these are major component of industry 4.0. So one of the component over here, that is IoT. So all other component over here like big data, AI, and sensors, 3D printing or robotics, digital technologies, and data analytics, all these are major component of industry 4.0. So when we talk about industry 4.0, we have to understand sensor also, AI also, and now IoT is one of the major component over here. So when we talk about IoT, so over there we have to learn sensor also, artificial intelligence also, robotics also. All these things you can integrate with the IoT, and you can build any smart product. So IoT ecosystem over here that you can see it, there are different domain over there. IoT is interconnected. So when we talk about IoT or any smart product, all these things are integrated. So I will share with you a few example. You can see this robot also. This one is a mechano-electric robot over here, but over there, all these things are integrated like IoT, sensors, AI, robotics, big data, 3D printing, cloud computing, everything is integrated over there in this product that you can see. Now, when we talk about IoT ecosystem over here, you can just visualize in a very simple way that how new technology is going to put impact in a human being. So over here you can see it that in upcoming 10 year everything will be fully automatic and smart. So when we talk about smartness, so what level of smartness over there that you can visualize in a very simple manner. So as you are going to wake up from your bed, you are going to get dressed or with the help of a robot. And as you are going to wear your suit, and your car will come automatically from the parking, and with the help of that sensor that is being deployed on your suit, and you will go in your office directly. So everything is fully smart, fully connected with each other, and flexible also, so that you can visualize over here. So now when we talk about IoT, how IoT is exactly and what IoT is over here, that you can see it. So in IoT there is three major components, that one is sensor and actuator, second is connectivity, and third one is people and processes. So when we talk about sensor and actuator and connectivities and people and process, all these components are interconnected. So we have to start from the sensor and actuator, and after that we are going to talk about connectivities, and then we are going to talk about people and processing. So what are these things? So first of all, let's see sensor and actuators. So when we talk about sensors, just take some examples. So when we talk about artificial intelligence or smart machine, so just visualize and take an example of human being. What are sense over there? So similar kind of sense we have to develop in that particular machine. So these are common sense over there, that is vision sensor like eyes, and acceleration and tilt, that is sense of vibration and speed that we can detect it. Then electric and magnetic, with the help of that you can detect directions. Leak and level, so with the help of that you can detect any kind of leakage, and force and load, torque, strain and pressure. So with the help of that you can detect these parameters. These are sensors. And over here you can see it, a very simple flow sensor, chemical and gas sensor. With the help of that you can detect any kind of leakage. So recently, earlier 2 months before, so in a Visakhapatnam there was one incident over there, that was leakage of gas over there in a particular plant, and more than 14 casualty took place over there. So these kind of casualty can be avoided using IoT and building smart devices over there in a factories to detect any kind of chemical and gas leakage over there. So similar way, acoustic, sound and vibration sensor, with the help of that you can detect brain signal also, ECG signal also. So these you can detect it. humidity and moisture, and temperatures, motion velocity and displacement, position, presence, and proximity. So all these things you can detect it in a very simple manner. Close it. So that you can detect it over here. So now when we talk about all the sensors, how we can integrate it, that is very much important. So first part in IoT is that acquiring sensor data. So the second part is that after acquiring sensor data, we have to send the data to the cloud. So over there we need a connectivity. So how we are going to connect these sensors with the cloud, that is very much important part, and that is second step, that is connectivity. So how you are going to connect it? So take a simple example, in a RFID tag is being used in a toll plaza. So FASTag might be, you have heard about it, that is mandatory for all the vehicles when they are traveling in a highway. So with the help of that FASTag, when you are going to pass that particular toll, so the charges of that particular toll will get struck automatically from your account using that FASTag. So FASTag is working as a sensor, and after that, that FASTag is being get connected with the cloud. Mean all your sensor data is going on a cloud, and over there that is connected with your payment gateway, so that you can see. So now similar way over here, these are different mode of connecting with the sensor with the cloud, like RFID, antenna, NFC. So NFC, take an example of NFC. NFC is a wireless mode of communications of the sensor. Like take an example of metro. Over there, that metro card is being used. That card over there, RFID, sorry, that NFC tag is there. So when we are going to scan that card, so over there that payment is being get stuck automatically from that card. So that is based on NFC. So this NFC is also coming in latest mobile phone also. So you can do directly payment with your mobile phone without scanning anything using NFC. So that also can be done. So similar way, there is LoRaWAN and LoRaWAN also, Zigbee and Z-Wave also. So when we talk about LoRaWAN, that is being used for long range communications. Like if you have to communicate up to 10 kilometers without having any kind of internet connectivity or without having any kind of mobile network, that also you can do it using LoRaWAN. So then after that, Bluetooth for long, very short range communications, like if you want to communicate up to 10 meter, so for that you can use the Bluetooth module. And after that you can use Wi-Fi module also over there, and you can use different other mode also, like 2G, 3G, and 4G. Now we are going to enter in a 5G also. So all these mode also you can use it with mobile, like cellular, 4G, 3G, GPS, GPRS, GSM based, so weightless, WiMAX. These are some dedicated spectrum. So LTE advanced, that is 5G, that is coming in these in upcoming few months. So now when we talk about all these mode of connectivity, and after connecting all these devices, what we can do some process. So some people and process, that is very much important part over here. So when we talk about people and process over here, just simply see over here that when we are going to acquire sensor data, after acquiring that sensor data, we have to send that data to the cloud. We did it like with the previous step. So now what we have to do with that data, we have to process that data. So how we can process that data, that is very much important over here. You can put some analytics over there, and you can use AI over there, and ML also you can implement over there with the data, and you can perform some applications. So some cloud API also you can build it over there. So you can upgrade, and configuration of a machine can also be done from that cloud. You can do remote monitoring of your machine or your vehicles, and you can do remote maintenance. You can do control and automation over there using your cloud. You can use supply chain management from that cloud. That process you can implement it, security and energy you can monitor it, mobile device and app also you can build over there, and financial assistance you can also do it over there, location tracking also you can do it. So all these things you will able to monitor it and you will able to control it also. So these are people and process, all these integrated on the cloud, and you will able to make over there one dashboard, and with the help of that you can see everything. So take an example of very simple example of IoT, that is Ola and Uber cab facilities, their app. So when we talk about Ola and Uber, so how process is being carried out over there? So when any customer is going to book any ride, so that customer is using mobile phone, that is things, that is device. So in a mobile phone is connected with the internet. So your mobile sensor data like that using GPS, your mobile sensor data like acceleration, gyroscope and magnetic sensor data that going on the cloud as you are going to book any ride. So your data is going on the cloud of that Ola and Uber cab cloud, and from that cloud there is analytics is being performed over there in that particular cloud, and some algorithm is being implemented. So a simple algo I'm just sharing with you that first what they are doing, they are going to find a driver nearest to your locations. That is first algorithm. So the driver are also connected with their cloud. So they are going to check it out that this driver is nearest to you. That is first algo. Then they are moving towards second algo, and they are going to check it out over there that which driver is having highest rating, and according to that priority they are going to share their ride with you, and you will able to access driver location directly. So driver is connected with their mobile, and that is device, and you are connected with your mobile. That is real example of IoT, and that AI is being also performed over there in that cloud. So that is real application of IoT. When we talk about IoT, IoT is integration of all these things like sensor and actuators, and then after that connectivity, and then people and process. So after combining all these activities like sensor, connectivity, people and process, we are going to build some smart applications that you can see it. These are smart product, latest products that you can see it in a market, like a smart thermostat. With the help of that, you can control your home temperature, and you can control AC from remote area. So these are companies, those are making it, and those are not right now in India. So you can work in these product, and that can be very helpful for the society also, and they are needy in this time. So you can move over connected cars, and there is one application that I'm just sharing with you, that is based on US, and that is car to go. And over there they are going to do rent their car, and they will able to track their car in a with the help of IoT. And then after that, third one is activity tracker. So there are many health band, might be you have heard about that MI band and Samsung band, and many more band is also coming in these days. So with the help of that, you can track your heart rate, and how many steps you run, and how many calories you have burned today. So everything you can monitor over there in a very simple way, and everything is being get paired with the cloud, and that analytic is being get performed over there. Now after performing over there these things, so now you can see it like smart outlet over there. So these are also very much important over there. So you can make a smart outlet in a very simple manner. So with the help of that you can control it. So now third one is parking sensor and the street line. So with the help of this one is very important application when we talk about any interesting product over there. So that is very much important over there. So now with the help of that, what you can do is you are going to do in a any congested area over there, or over there high traffic is there. So when we are going in any parking slot, so it's very tough to find any parking vacant slot over there. So what you can do, you can build some kind of application like this, and if there is any parking slot that is vacant, that you will able to identify with your app, and that navigation is being get on over there, and you will go over there in that particular vacant slot of the parking, and you can park your vehicles. So that is very much important in a smart cities over there, and that is being implemented in upcoming days. So now you can see over there, there is some diverse application over there like home, consumers, transport and mobilities, health, body, building infrastructure, cities and industries. So these you can see it in a very simple way that what are diverse application like in a home, light, bulb, security, pet feeding and all these things that you can see it in a transportations like traffic routing, telematic, package monitoring, and in healthcare like patient care, elderly monitoring, remote diagnostic. So these are also helpful in a like monitoring of for that COVID affected patient and all that. So that also you can monitor with the help of that smart applications. You can build the infrastructure also. You can work in a building infrastructure like security, lighting, electrical, transit, and many more applications in a smart cities also that you can see it. So some compound application that transportation plus smart cities. So that also you can integrate like if you your vehicle get faulty anyway in between your traveling, so that mechanic will come automatically near to that vehicle locations. So that also get integrated, and smart parking is also integrated with your mobile app. So all these are integrated applications. So healthcare plus smart home, smart building plus mobilities. So some real-time services also like this one is a digital farming. So cattle farming over there, you can monitor the cattle using RFID tag, and their health also you can monitor it, and their food also you can monitor it. Everything you can make it automatic, and you can get maximum production out of for that particular cattle farming. So how large is IoT market? So that quickly I'm just going to share with you. So in 2014 there were only approximately 2 billion connected devices, and now in 2020 8 billion connected devices. So that you can see it how much fast that IoT market is growing. So you can see over here that is exponential growth of IoT market. Like home transportation over there, you can see it from 2014 to 2020. So these are revenues. So by 2020, that revenue in 2020 revenue is more than 1 trillion. So that you can visualize it how much potential of IoT market. So there are a few more diverse application of IoT that you can see it: smart building and energy, environment, agriculture, logistic, home automation, smart cities, manufacturing, everything you can see it over here. So then industry 4.0 value chain. So when we talk about industry 4.0 over here, you can see a value chain, and IoT is very much important over there. So every process is being carried out, and all the process data is going on the cloud. So in a cloud, different analytics is being get performed over there, and with the help of that, you can monitor your complete process from any remote area. That also you can do it. So when we talk about industrial robotics, so and integration of IoT with robotics, that is also very much important. So see it over here. When we talk about any food processing industry, over there everything is being done with the fully automation that you can see. So over there you can see it like painting of particular vehicles, welding, and over here like assembling, cutting, and making some building also. That also can be done using robot. So you can just visualize in a very simple way that how that AI and automation is being integrated in industries using IoT. So you can see this one is a manufacturing plant of particular four-wheelers. So over there you can see it that one product is coming out in a 1 minute. So this one is product cycle over there, and the one vehicle is coming out in a 1 minute. That you can see it. So now over there you can see it that how fast production is going on, and just visualize it over here in a very simple manner that in a 1 minute that one vehicle is coming out, and if that one product is not, if 1 minute that production will get stopped, how much loss will be over there, that you can see it in a very simple manner. Now you can see it over here. So in a very simple manner, so now over here you can see it in a very simple manner. So now what we can do, that if we are going to integrate IoT, IoT is already integrated. So if any particular robot got damaged, so before going to get damaged that robot, so we can analyze that which robot is going to get damaged using IoT. We can call it like forecasting of particular fault that going to occur. So that we are calling in industry point of view, that is condition monitoring of that particular machine using IoT and AI. So few more example. So AI integration over here. So this kind of robot can be helpful for fighting that COVID-19. And now we are entering in a 5G. So with the help of that, more connectivity will be over there, and more devices will be get connected with each other. So in a 3G, 4G, and now we are going to enter in a 5G. So there are some disadvantages also. When we are going to make anything, we have to work in a perfections. That is very much important. So in upcoming days, everything will be connected with the IoT, and you can see a robot is also being integrated at your home also. That home automation using fully robotics, that you can see it, that all home task is being done by a robot. So everything is integrated over there. So there are some more example of faulty component. You can build something for your own application also. Yes, when we are going to make anything wrong in industry, so how boss is behaving, that you can visualize it. When any student having lack of knowledge and that working in industry, so boss is behaving like this. So just when we talk about IoT and AI over there, that basic of electronics component is very much important, because over there we are going to integrate sensor, we are going to design sensor, and we are going to develop sensor over there. That is very much important. So these are capacitors, and you can see it in a very simple way, and every component is very much important. So when we talk about these capacitors, so if you are going to use any capacitor in a reverse polarity, that you can see it. So is a reverse polarity, if you are going to connect it, that capacitor will get blasted like this, so that you can see. If that capacitor is being get deployed in an aeroplane, so in a reverse polarity, what can be happen over there, that you can visualize it in a very simple manner. So huge casualty can took place over there. So that is very much important, that every component is important, and we have to work on a precision. So when we talk about IoT, IoT is integration of many branches like electronics, electrical, computer, mechanical. So we have to work on a multidisciplinary approach, so that you can see it. So like resistance, you can see it how resistance is working. So you can see it like this one is a resistance over here, and this one is a voltage. Voltage is trying to pass over here, trying to pass current, and resistance is opposing flow of current, that you can see. So these are color coding of that resistance, that how you can identify their values. So this one is a very first component we are going to start hands-on using this, that is LED. So in LED, there is two terminal over there. One is the positive and second is negative. So you can see it that bigger lag is positive and smaller is negative. And when we talk about in detail over there, that you can see from the internal part also, that bigger flag is negative and smaller flag from the inside, that is positive. And that flat part over here in this LED that you can see it, that is that flat part is negative over here. So with the help of that, you can identify positive and negative in LED and you can connect it. So when we talk about any industrial process, so those processes are manual, so you can make it automatic. So in a manual process, there is a lot of chances of failure over there. Earlier, one year before, there was one incident, that incident, or we can call it accident, that took place in a NTPC plant in a UP, Uttar Pradesh. So over there, one boiler got bursted and many casualty took place over there. So that process were over there in a manual way. So due to some worker fault over there, so that accident took place over there. So that can be avoided by making it automatic. So mean if that worker is going to get some lap of sleep, so that can be more dangerous over here. So there can be any human error over there, and that can leads to a very big accident. So that can be avoided by making it automatic. So sometime you can see that kind of activity can also took place over there, so that can leads to a big accident. So that can be avoided, like some one worker is one that the boss is available and watching it, watching workers. So they are working like this, they are looking like that they are doing their whole company job over there, and when boss is absent, so worker is working like this, so that you can see it. So that we have to avoid it and we can make systems automatic. So these are different microcontroller and microprocessor. We can use it for IoT applications. Like first one is a microcontroller and microprocessor over here. So these are two microcontroller and microprocessor. This one is a microcontroller, that is Arduino Uno, and this one is a microprocessor, that is a Raspberry Pi over here. So both of them are open source and you can use it for IoT applications, and you can build your industrial product also based on these open source devices, and you can make your own product also using these devices, because those are open source. So there is no need to worry about royalty and license of all these software and hardware. So those are free of cost. So we are going to talk about right now using microcontroller Arduino Uno, and we are going to use it, and we are going to use Raspberry Pi also. So first we are going to work on that Arduino microcontroller development board, and then after that we are going to integrate all the sensor with this, and we are going to send data from this microcontroller to the cloud using Wi-Fi module, and that also we are going to do it. So first we are going to understand that Arduino Uno, that how it is working. So if you are not familiar with microcontroller, you can see it. So this one is a microcontroller over here, that is 8 mega 328p, and these are analog pins over here, and these are digital pins over here from 0 to 13. So these are power pins over here, means with the help of these power pins you can give output from that microcontroller to your sensor, and you can power to your sensor over here, over there, with the help of this these pins. This one is the external power. You can provide power to this jack if you are not going to use USB. So if you are going to use USB, so you can power it directly from that USB, and you can program it also from that USB. This one is a reset button, and these are ground pins over here. Two ground is over here and one ground is over here. So when we are going to use this microcontroller, so we have to use those digital and analog pins over there for reading any signal or reading any sensor value or writing anything on a actuator. Actuator mean any kind of relay or any kind of motor, pump, anything, whatever we want to control it. So that is about Arduino Uno, that is available in the market, so that you can use it. So this one is tool that we are going to use it to learn that Arduino and their sensor interfacing and their programming. We are going to use it. So let's see it over here. So now what I'm going to do, I'm going to use it. So let's see it how you can use it. This one is a simulation tool, and that is free of cost tool that you can use it for learning Arduino, learning IoT application in a very simple manner. So let's get started. So this one is an online tool, no need to download any software. You can use it in an online mode, and it will work fine over there. So now in this Tinkercad, you can see it and you can visualize it. First of all, you have to open the Tinkercad in Google directly. You can also do it. Let me to sign out. So directly you can search on the Google with the name of tinkercad.com. So I'm going to search on the Google that how it will look like, Tinkercad. So as you are going to search with the name of Tinkercad over there, you will find like this, Tinkercad. So that you can open it. So that is website of tinkercad.com. The tool is being developed by Autodesk company. Now after that we have to click on sign in, or you can do join now if you are doing it first time. So I'm going to click on join now. So you can create a personal account over there, create a personal account. Third one option you have to click it. So after that you have to do sign in with Google, or you can do sign up with the email also. So sign in with the Google is a very easy step. So you can click it over there. If you have already signed in over there in your Chrome browser, you will be able to join it. So it will ask account number or their permissions. You can allow it, and after that you will be able to log in it over there on a Tinkercad. Now this one is the home screen of the Tinkercad, and over there you will be able to use it. So now what we are going to do it, first of all, after doing sign in on the Tinkercad, you have to go to circuit. In a circuit, you have to go to over there, and over there you will find previous circuit if you have created it. But if you are doing it first time, you will not find previous. You will find something like that. Try it now. So no need to do it directly. You can do create new circuit. So that you can click it, create new circuit. So as you are going to click on a create new circuit, so what is happening over there, you will able to see a new workspace over there, and you can make your circuit, you can design your circuit, and you can simulate your circuit. So how that workspace is look like, that you can see it. So this one is a rotate window, or you can do rotate tool, you can use it. So these are all the component libraries. As you are going to scroll down, you can see all the component libraries. These are basic component. You can see, click all. So over there you will find all the component, capacitor, resistance, buttons, sensor, all the keypad, LEDs, all the detailed component, motors, servo motors, buzzer, LCD, and after that
Screen is not visible. Please share again.
screen. Okay, so let me share it again. Is it visible now, sir? Screen is visible.
Okay, sir. Okay.
Okay,
Now
Yes,
okay.
sir.
So that you can see it all the component over here, their component libraries. Sir, kindly mute your mic. Your mic is not muted. Okay, thank you. So all these component library, you can see it over here in the Tinkercad. So Arduino is also there, some op-amp is also there, the timer ICs and optocouplers, so transistors, so all the MOSFET also over there, regulator also you will find it over there, motor driver IC also over there, so connectors, so logic gates, everything you will find it over there, and you can make interesting projects over there, and without having any hardware. So now what we are going to do it, we are going to make any circuit. So let me uh, go to basic. So I'm going to take one LED, and you can just drag and drop over there. After drag and drop, you will able to uh, connect it, you will able to use all the tools. So this one is a zoom to fit tool, so you can do fit to screen over here using this, click over here, and this one is your component. So which one is positive and which one is negative, that you can see it is you are going to take your mouse cursor over there in that end of these two terminal. You can see this one is cathode and this one is anode. Anode is positive and cathode is negative. So after that you can rotate it using this tool, select it and you can rotate it. You can delete it and you can undo it, you can redo it, and these are annotations. You can use annotation also, like this one is cathode, you can write it also over here. Where is this one is anode. So whatever you want to write, that you can write it over there in a very simple manner. So you can hide it also, that also you can do it using it. This one is a coding block. If you want to write code, that also you can write it. So for that you have to select your microcontroller, and after that you can write coding also. You can start simulation using this, and you can share your circuit with your students, and you can see your student circuit also using that share options. So now what we are going to do, we are going to use some batteries over there. So that battery you can take it, and you can connect it. This one is anode, anode is positive, so you can connect it. Cathode is negative, you can connect it over here like this. So this one is your circuit. So as you are going to start simulation, so what is happening, your LED will get damaged. So why it is so that your LED get damaged, reason behind that, LED current requirement is 20 milliampere. That is also written over here. As you are going to take mouse cursor on the LED, it is saying that current through the LED is 950 milliampere, and while absolute maximum required is that is 20 milliampere. So that you can see it. So now what we are going to do it, we are going to use some resistance over there. So you can delete it by selecting it, and after that you can take resistance. You can directly delete it using this also, or you can use the delete button over there in your keypad, that also you can use it. So I have just connected one resistance over there in a series, and I'm going to start simulation. Now it is working fine. So that value also you can calculate it using Ohm's law, and you can use exact value also. Now that is 350 ohm resistance is optimum value, and now LED is working fine with no error. So as you are going to reduce that resistance value less than 350, so it's showing some warning over there. So what is warning over there? So that warning is that current through the LED is 21.5 milliampere. Mean if you are going to use this LED in this condition, so after a long time it can get damaged. That lifetime of that LED will get reduced. So that is very much important. So these are basic component over there that you can use it, and you can make circuit over there in a very simple manner. So I'm going to talk about now with the sensor, that how you can use sensor. So this one is one sensor, that is photoresistor, and we can call it LDR. LDR stands for light dependent resistor. So in this LDR sensor, how it is working, this sensor will detect light intensity, and as we are going to change that light intensity, what is happening over there. So as we are going to increase light intensity, that resistance of the sensor will get reduced, and as we are going to increase darkness and reduce light intensity, what is happening, the resistance of the sensor will get increased. So this one is a resistive type sensor, we can call it. So where you can use it, you can use it for making automatic street light, and you can use it for turning on and off your balcony lights and all that automatically. That also you can do it. So now how you can use this sensor in a very simple manner. So I'm going to use one motor and going to check it out that how the sensor is working. You can rotate it. So this battery I have connected it. So now after connecting this battery, I'm going to start simulation. So now you can see my motor is running with RPM negative is representing that anti-clockwise, because I have connected negative with positive and positive with negative. That's why it's rotating in a reverse direction or anti-clockwise direction. So over here you can see it in a very simple manner, -6 RPM over here. So -6 is representing that RPM in anti-clockwise direction, and that is very less. Now I'm going to click on this sensor. So let's see it, how you can use it. So as you are going to click on the sensor, it is showing that this one is a darkness and this one is a full light intensity. So as you can slide it, that arrow is representing that you can move it in this direction. So as we are going to rotate it, you can see that resistance of this sensor is reducing and RPM is increasing. Mean more current will start flowing over there, and you can see that RPM is increasing. So now my RPM is increasing over here as I'm going to increase my light intensity, and at full light intensity you can see that RPM is approximately 2000. So that you can see it. So now that you can simulate it in a very simple manner, and you can control your motor speed according to light intensity, and based on that you can make some project also. So now I'm going to use another sensor. We will talk about that programming also, but first we are going to discuss about basic of that sensor, that how you can use it. So this one is a PIR sensor. So PIR stand for proximity infrared sensor. So when we talk about PIR, so that PIR sensor is being used for detecting human being. So few applications that I'm going to share with you, might be you have seen few automatic door at a hotel or restaurant over there. So those automatic door is based on this PIR sensor. So this sensor is being used for detecting human being and their presence and their motions. So if any person is moving and coming in front of this sensor, it will detect it and it will give output high. So let's see it how you can use it without microcontroller. So I'm going to use it. So you can use some battery, but it required 5-volt battery. So you can select power. So you can take some batteries over here. Yes. So this one is battery. And you can use some batteries like potato batteries and lemon batteries also, and you can try at your home this experiment, and you can make this battery at your home, and you can check it out over here, that simulation, and you can do practical using that lemon battery and potato battery. So this one is my power supply, that is variable power supply. So I'm going to connect negative with negative of this sensor, ground, and then after that positive we have to connect with the power. Then we have to give power to the sensor, and you can change their color also. You can make it red. This one you can make it black. So this one is signal output. So that output you can connect with any buzzer or any LEDs, whatever you want to do it. So that output I'm going to connect with a motor or LED. You can do it. So I'm going to connect with the LED. Negative you can connect with the negative, and positive of this LED you can connect with output. So now what you can see, you can set that voltage, that is 5 volt, and you can start simulation. So now you can see it, we are providing 5 volt to this sensor, and output we are getting from the LED. So this one is the range of the sensor, so that you can see it, the range of the sensor. So if any object coming in front of this range, this one is object. So this just pose it, this one is a human being, and as human being is coming in front of the sensor, that light is on, and person will get past, light will get off. Again that person is coming, light will be on. So that project can also be made over here, and that product also you can make it smart product over there. So with the help of that, what you can make many application to fight COVID-19, and you can make many smart products over there in a very simple manner for detection of just making a social distancing gadget, that also you can make it using this, and you can make contactless that doorbell also you can make it a doorbell using without contact, using this PIR sensor for detecting human being. You can use it. So that you can make it in a very simple manner. So that is use of PIR sensor over there without using microcontroller. So this one is range of this sensor. So if any person coming in this range, then only it will work. So now we are going to talk about, there are many more sensors over here that you can use it, like ultrasonic sensor and temperature sensor also over there. So now I'm going to use microcontroller over here, and you can save your circuit also. So how you can save your circuit over there, the name of the circuit you can rename it like PIR testing. I'm going to write it over there, and after that you can click over here in this workspace. So your name will get renamed automatically with the PIR testing, whatever name you have mentioned over there. And after that you can go to home screen, home window using this Tinkercad. I'm going to click it. So as I'm going to click it over there, you can see it. This one is your latest project that you have saved it, and that is PIR testing. You can open it also. So you can tinker this, and that will get open. So now I'm going to create a new, and we are going to use microcontroller over here, that is Arduino Uno. So you can use Arduino Uno only over here, not Raspberry Pi and all that. So I'm going to use microcontroller. You can find it, that is Arduino Uno over here, that you can take it, drag it and drop it. So after drag and drop over here, what you can do, you can do programming over there, and you can interface sensor over there. So now what we are going to do, we are going to take any LED, and I'm going to connect it on a 30 number pin, that is digital pin over here, 30 number pin, and after that I'm going to start simulation. So my LED is blinking over here, that you can see it. So because I have not written any code over there, so how it is blinking, because you can go to the code and you can see that program is running over there. That is by default program for 30 number pin. So there is one inbuilt LED also. This program is by default for this LED that is connected on 30 number pin. So that is high for 1 second and low for 1 second. That programming is known as over here, that is graphical programming. If you want to write with your own, that also you can do it. You can delete this block using this dustbin. So these are all the menus over here, like all the blocks, main uh, menus like output, input, notations, control, math, variable. So according to your requirement, you can use output or input, and in a control you will find all the if and else conditions like wait, loop, and all the function, you will find it over there. In math you will find some operators and some math function over there that you can find it. In a variable you can create your variable and you can use it, so that you can use it. So I'm going to delete it, so you can drag and put it on a dustbin. Now you can write your code. So I'm going to write output. So this one is built in, that is by default, we have taken it earlier. I'm going to take the second block. In this block you can select the pin number. So pin number we are going to use it over here, that is 13 number pin. This one is high. Then you can go to control. Over there you will find wait. Wait means delay, mean that LED will be on for 1 second, and after that what you want to do it, you can go to again output, take that second block, select pin number 30 number pin, then go to control, then wait. So this one loop will repeat for infinite time. So if you want to repeat it for 10 time only, then you can put it over here 10 times. So this one will be high, you can make it low. So this one will repeat for 10 time only. 10 time LED will be on and 10 time LED will be off over there, that you can see it in a very simple manner. So now over here what you can see, that LED will be work for 10 time, and after that 10 time it will get it will not work, so that you can see it. So it's continuously working. So 10 time it will go on over there, and when you want to see that embedded C coding also, that also you can see it in a block plus text. So you can see that for loop is working and it will run for 10 times. So that you can see it. This one is embedded C code. That code will generate it automatically. So when you are going to deploy any code with this microcontroller, you have to use that embedded C code in a hardware. So that embedded C code will be generated automatically over here, and that you can see it. Now what I'm going to do it, I'm going to delete it. So as you are going to delete it, your code will be get deleted. Again you can make it output, select it, pin number 13, and you can use control delay, and one more option is over there for making it fast. You can right click over there and you can duplicate it also. So you can make it low, so that code will generate it automatically over here. And now you can start simulation and you can reduce the delay also. So I want to blink my LED fast, so I'm going to make it 300 millisecond, 0.3 second. So over there also I'm going to make it 0.3. So now after that what I'm going to do it, I'm going to start simulation. So you can start simulation, and you can see it, LED is blinking fast. So LED will blink for 0.3 second on, 0.3 second off, that you can see. So now your code is over here, and if you want to use this one will run for infinite time. This one is a loop for infinite time, and if you want to run it for only 10 times or 5 times, that also you can do it, and you can start simulation. So this one will run for only 10 times over there, like we have used earlier, but now LED is blinking with a fast rate. So on off it will goes for 10 times. So now I think it's continuously working. Again going back to that loop, for loop counter. Okay, that is going on over here. So that will run for 10 time, but due to that software issue, that going continuously running over there. So similar way you can write code over there. So let me remove this one. So that is high and low over here that you can see it, and you can change that pin number also. I'm going to make it on 12 number pin. Pin number will get changed, and you can start simulation. But before that, we have to connect any LEDs on 12 number pin. So this one LED, I'm going to connect it on 12 number pin. So you can delete it also, and you can connect it again with 12 number pin. Now you can start it. So LED is working on 12 number pin. It will not work on 13 number pin. So as we are going to start simulation on 13 number pin, it will not work because we have changed that pin number in a code, that is 12 number pin. So that coding you can do it over there in a very simple manner, that high, low and reading sensor also you can do it, that we are going to do it. But before that, I will let you know that how you can learn that graphical coding in a very simple manner. So if you want to learn that graphical coding, so how you can learn it. So these are blocks over there, how you can understand it, because if you are doing it first time, might be you face difficulty while writing that code, that where you will find input, and where you will find sensors, and what is the meaning of all other blocks over there, speaker and all that, and how you can understand it in a very simple manner. And with the help of that graphical coding, you can generate your embedded C code, and that code you can deploy it in a hardware, and you can test it over there in this circuit over there. So now what I'm going to do it over there, I'm going to uh, understand that coding, graphical coding. So that graphical coding is known as Scratch coding. So Scratch is one of the software that is being developed by MIT, that is Massachusetts Institute of Technology in Massachusetts in USA. So they have developed that Scratch software, that this coding is based on that Scratch. So how that coding you can learn it and you can understand it in a very simple manner. So for that, I'm going to open a new window, and over there I'm going to open that Scratch software. So that is also open source, scratch.mit.edu. So that also you can search it on the Google. That you can search it on the Google, and after that you will able to find this website. So Scratch is a visual programming language, and website is targeted to learn to children to help to learn code. I'm going to open it. So after opening it, you can sign in over there, or you can directly start creating over there. So I'm going to create. So it will get open like this. This one is your workspace, and over there you can do coding. These are few tutorials that also you can watch it, and you can make interesting things over there. So I'm going to use my cat. This one is my cat, and you can use that graphical programming over there. So these are blocks over there. There are menus over there, so like looks, sound, events, control, sensing, operators, variable, and my block. Customized block also you can make it. So all these blocks are available over here, and you can use it, and with the help of that you can simulate this cat. So I'm going to do it. I'm going to use motion, move it 10 step, then rotate 15 degree, and I'm going to use some delay after that. So you can go in an event or control, over there you will find delay, and after that again I'm going to move it same, you can duplicate it. So that I did it, and after that what you can do, you can use some events over there. Wait, repeat in event, and you can see some look mean you can say hi, hello. So you can say hello over there, and you want to repeat it for a particular time, like 10 times. You can repeat it 10 times, and after that, if you want to play some sound, that also you can do it, but that I will do it later on. So now let me check it out how it is working. So this one is a simulation tool, and that you can use it flag, but for that you have to use that event flag. So as you are going to click over here or over here, it will start run. So I'm going to click it over here. It is working over here, that you can see. So it's saying hello and it's rotating. So it will rotate it up to 10 times. So now what I want to do, I want to say some sound also, because my cat will want to use some sound over there. So that I'm going to use it. So go to sound, and over there start play sound. So my cat, every after completing every step, my cat will say sound meow, or you can at the end also you can say it some sound of meow, and that you can do it. Now I'm going to use some delay. So my cat will say meow at the end of one loop. I think everyone is able to hear that meow sound.
Yes, sir.
So mean my cat is rotating, and at the end over there, and it will saying meow after completing one loop, and it will rotate for 10 times. So after 10 times it will get stopped. So now it will get stopped over there. So similar way you can understand all the graphical programming over there, and that graphical programming whatever you are going to use it over there, that is being used over there uh, in this Tinkercad, and with the help of that graphical programming you can generate embedded C code over there, so that you can do it. So a few more interesting creativity you can do it over there in a Scratch, like over here that you can see it, like costume. That costume, this one also you can change it. Any modification you can do it over there, and few more costume you can select it, and that also you can use it. Like this one bat you want to use it over there, that also you can use it, and there is different motion look. In a look you can see different costume. So flying of this bat also you can do it. So I'm going to use it, this one, and the next costume, back to, okay, this one I'm going to delete it. So you can repeat it also, go to control, repeat it 10 times. So that costume you can play some sound also, whole sound also you can play it over here, or at the top also you can do it, and this one you can repeat it. So let me take some more looks. Next costume B, and you can duplicate it. So for, okay, for costume I'm going to take it over here, A, B, then after that C, then D. Okay, so let's see it. After that I'm going to simulate it. So this one, okay, let me uh, use one event. Okay, so both will get simulated simultaneously. So let me start simulation. So this one is a little bit fast over there. I have to use some delay. So this one is owl sound and the meow sound, both is there, but that costume is not shifting, so you can use over here ABC, so you can use some delay also in between that, so that you can see it properly. Now you can see it is working fine. So this one is owl, both you can see it simultaneously working. So that is I mean you can do a lot of creativity over there in this Scratch software, and that you can implement it in a hardware over there. When you can check your circuit over there in this coding, and you can make your code in a very simple manner. So that is about just simple input and output using this graphical programming. Now I'm going to use that digital input and digital output. So that is very important in a programming in a microcontroller. So when we are going to use any digital sensor, so we can use the digital input over here. So let's so let's use over here the digital sensor. So I'm going to use the digital sensor over here. So that PIR sensor is a digital sensor. So that PIR sensor I'm going to use it over here. So let's use PIR sensor. So let me delete it. So I'm going to select one sensor, that is PIR sensor, and that I'm going to use with microcontroller. So you can use it. So I'm going to connect signal wire. You can connect with any digital pin because that sensor is based on digital. So after connecting that signal wire, you can do color coding also over here, green, yellow, whatever color you want to take it. This one is power you can connect with 5 volt and make it red. Then this one is ground you can connect with ground, black. So all these pins you have connected it with the sensor and microcontroller. Now you have to write code. So go to the coding, and over there this one is by default, as I told you, we made it earlier. I think this code you can delete this code, and otherwise you will find that by default code also over there that you can delete it by putting it on a dustbin. And after that what you can do it over here, and you can use your own code. So you can go to input, because now you are going to take input in the microcontroller using sensor. Earlier we were giving output, that is digital output. For taking input, click on the input menus, and after that you can use first one block, that is read digital pin, and you can take it. Then after that you can select your pin number. So you are going to use 3 number pin for reading that digital signal of this sensor. So you can use 3 number pin. So 3 number pin we have selected it. After reading that value, we are reading that value on pin number 3. After reading it, we have to print it on the serial monitor so that we can visualize that value in a very simple manner. So I'm going to print that value on the serial monitor. So where is my serial monitor? Serial monitor you will find at the bottom. This one is serial monitor. Right now there is nothing. So for that we have to go to output over there. I'm going in output. So in output, what you can find it over there, you will see that these are blocks. So at the bottom you will find pin to serial monitor. So you can take this block and you can put this value over there, because this value you want to print on the serial monitor. Whatever you are reading it on 3 number pin, that value you want to print on the serial monitor. If you are not going to put it over here and you are going to start simulation, so that hello world will be get printed over there, hello world only, because this block is printing only hello world. So now I'm going to put it over here. Yes, now you can start simulation. It will display that value of the sensor. So that is by default 0 now, and as your any person is coming in front of it, it will show 1, that is high. So you can see it if there is any person over there. So this one is a sensor, so I'm going to do any motion. So any person is being detected, you can see that value is high. So after that value will be low. So if any person in front of the sensor, value will be high, otherwise value will be 0. So that value you are reading it, that is 0 and 1. So now after that, what you can do with the help of that value, you can use some condition also over here. If you want to make automatic street light and automatic doorbell, that also you can make it. Now we are going to make a product or project over here, that is automatic doorbell. So let's see how you can make automatic doorbell over here. So I'm going to click it over here and I'm going to make it okay. So I'm going to use if conditions. In a control you will find all the if and else condition. Take this if and else condition, and I want to use the if condition on my this value, so you can duplicate it. So as I'm going to fit it over here, it is not working. So what we have to do is we have to go to math, and in a math you will find that second block, that is comparison block. So I'm going to take it. So this will get fitted over here. You can see it. Now you can fit this block over here. So if my sensor value is equal to 1, so my condition will get satisfied, and I want to perform some output. So output I want to play speaker. So speaker I want to play on any pin. So I'm going to take on 8 number pin. So my speaker will get played over there with some particular tone and fixed tone. So after that, in else condition, what you want, that turn off speaker. So 8 number pin speaker will be turned off. So I have not connected any speaker on 8 number pin, so we have to connect it. So I'm going to take this PGO buzzer. So that buzzer we have to connect it on 8 number pin. So this one is positive. So positive we have to connect it on 8 number pin, and negative we have to connect it on ground. So that we did it. After that we have to start simulation. So we are going to start simulation over here. So simulation is being that started. So as we are going to start simulation, and now you can see it, if any person is coming in front of this in front of your door, and you have deployed that sensor over there in your door, so any person coming in front of your door, that buzzer will get on, so that you can see it. So the delay time also you can set it over here. If you want to make this buzzer on for particular time, that also you can make it. So I want to make it on for 1 second after a person has entered at your door. So that also you can make it. Any person coming and passed away, so buzzer will be, or that speaker will be on. So if you want to play some sound over there, some particular song or some particular tone, that also you can play over there in a very simple manner. For that, what we have to do it, you have to use different tones over there in a coding. So I'm going to use different tones over here. So if my condition gets satisfied over there, I want to use different tones. So let's see how you can use different tones. So over there, what I'm going to use, I'm going to duplicate this block, putting it over here, and this one is frequency 16 or tone 16. I'm going to make it 48. So I'm going to play that sargam tone, saregama padhani sa. So if you are having a little bit understanding with the music, you can play any particular music tone also over here. So one is 48, then after that I'm going to make it a difference of 3 51, so that you can do it. So after making it over there, what you can do, you can use 48, then 51, then you can duplicate it also. So over here you can make it 54, then 57, and up to you can continue it up to 7 tones. So now there is only 4 tone. So I'm going to duplicate it again. You can make it 60, then 63. These are 6 tone over here, and one more tone frequency also you can take it out. So all these things are in if condition. If my if condition will get satisfied, then only I will able to uh, give output of these tones. So those tones I'm going to play in this speaker. Let's see how it is working. So as we are going to start simulation, and any person coming in front of this, you can see it. I think you are able to recognize that sargam. So that is being get played. Any person coming in front of your door, so it is being get played that sargam tone. So again you can see it, sa re ga ma pa dha ni. Ni is not available because 6 tone we have used over there, so that you can do it. So any music also you can play it, any song also you can play it for with that melodies or with that particular their notes over there, so that you can use it. So these kind of interesting project you can make it over there in a very simple manner that you can do it. Now after doing this, that is PIR sensor interfacing, and that is a digital input we are using. So now we are going to talk about analog input. So what is analog input and how we can use it, and after that we are going to talk about analog output. So these are 4 terms in a microcontroller, like digital input, digital output, analog input, and analog output, that we have to use it while programming it or interfacing any kind of sensor over there with the microcontroller. So now what we are going to do it, we are going to use analog input. So before using analog input, we have to understand that input output over there. So mean how that input output is working and how analog input is working. So that I'm going to share with you. So when we talk about analog input over there, so we have to use few very important concept over there. So that is that is 8 bit or 10 bit concept, because when we are using any kind of analog input, so over there we are going to use some ADC over there in this microcontroller. So that ADC we are using it over here, that is 10-bit ADC while reading any analog signal. So what is the meaning of ADC in a very simple layman point of view? That when we are going to provide 0 to 5 volt a voltage to the microcontroller on the analog pin, it will read in the format of 0 to 1023. Means you are going to provide voltage 0 to 5 volts, it will read in this scale of 0 to 1023. That scale will get magnified due to that their inbuilt ADC over there in a microcontroller. So that we are going to use it. So that we are going to check it out how it is working. So for that we can use the potentiometer, and we can make a connection of a potentiometer over there, and you can connect the potentiometer like this with microcontroller, and you will get output over here, that is 0 to 5 volt. So there is 3 terminal in a potentiometer: ground, input, and positive. So this one is working like this, so that I'm going to use it over here. So let's see how you can use potentiometer over there. So over here you can see it. Uh, this one is circuit. You can make it. You can name it over here. That is automatic doorbell. And you can save it. So my project got saved. So I'm going to create a new project. So now over here, you can create a new circuit. So this one is being get saved over here. This one is previous one. And now what you are going to do, you are going to build new one. So you can take microcontroller and you can take one potentiometer. So potentiometer is over here, this one. And these wires you can connect it with this microcontroller. So this one is wiper, this one is first terminal you can connect with the ground, and last terminal you can connect with a 5 volt. Then you can do color coding also. This one is black, and middle one is wiper, that is signal. So that signal wire you have to connect it with analog pin, because it will give 0 to 5 volt output, that is variable voltage. You can use multimeter also to check it out, that what output you are going to get. You can connect negative with the ground, and positive you can connect with the output. This one is output wire. So as you are going to start simulation without writing code, I'm just going to check that potentiometer right now. So after that I will write code for this. So it is giving 0 volt. So as you are going to rotate this potentiometer using this knob, so that voltage is changing, and that will change from 0 to 5 volt. So as we are going to supply 5 volt to this potentiometer, it will give output, that is variable voltage, output voltage, that is 0 to 5 volt. So we will get from this with the help of this potentiometer, that is variable output voltage, that is 0 to 5 volt. That 0 to 5 volt I'm going to read it in a microcontroller. So I'm going to write code for this. So this one is by default code that I told you, and now what you can do, you can delete this by default code over there. You can delete it. So I'm going to delete it. So after deleting this code, what you can do, you can go to over here, that input, and in input there is second block. Second block is read analog pin. So you are going to read it from analog pin over here, that is A0 to A5. As you are going to click it over here, only you will find analog pins over here in this block. So after getting this block over here, so what we have to do is, you have to print it on the serial monitor. Same step that we have used earlier. You can go to output, and over there you will find serial print, and you can put this block over here and start simulation. As you are going to start simulation, you can see on the serial monitor, at the 5 volt output you are going to read it 1023. Why it is so, that I said with you earlier. So as we are going to change it in between, so value will be equivalent to like this. So why it is happening, that I said with you earlier, that analog input we are going to take it over here, because there is one ADC, that is 10-bit ADC. So as you are going to provide 5 volt from any external battery or any potentiometer or any sensor, it will read in the format of 10 bit, that is 0 to 1023 or 1024, that you can see it. So it will read in the format of like this. So at 5 volt output in the Arduino, it will read 1023, and at 2.5 it will read 512, and at the 0 it will read 0. So that we have used over here. Now you can see it, that same value we are reading it from 0 to 5 volt, it will change. So that you can see it. So that is very important part, that is ADC, inbuilt ADC. Now same thing you can do it over there. If any project you want to make it using this potentiometer or any other sensor also you can use it, or any automatic street light project also you can make it. Many project you can make it. So all the project is based on like this analog input and digital input that we are going to use it for reading all kind of sensors. So now what we are going to do it, we are going to use some condition over there on based on potentiometer value, that also we can do it. So I'm going to use one if condition over there with this my value of potentiometer. So you can use condition over there, that if condition, if and else, and you can duplicate it. Then go to math, second block, you can put it over here. Now if the sensor value is greater than or equal to or less than whatever you want to make it, so I'm going to make it greater than equal to, so just take any value, random value I'm going to take it, that is 500. If my value will be greater than 500, then only my light will be get on. So you can give output to any pin, any digital pin, so that I'm going to select any 12 number pin. The 12 number pin will be high, and in else condition that 12 number pin will be low. So that I'm going to make it low. So that we can check it out. For that we have to use any LED on 12 number pin, then only we will able to check it out. So this one is LED, I'm going to connect it on 12 number pin. So that I have connected on 12 number pin over there. So after that you can see it over there in a very simple manner. So we can start simulation. So as we are going to increase that value, yes, as we are going to cross that value of that 500, you can see at the serial monitor also. So as we are going to cross value of 500, my light will be get on. You can see it at 552. So more than 500 value light will be on, and less than 500 value light will be off over there. That you can see it in a very simple manner. So you can use any kind of analog sensor over there in replacement of that potentiometer. That coding will be same and working will be same, only that interfacing of that sensor will be varying. So now I'm going to use that LDR sensor, and with the help of that what you can do, you can make automatic street light. So I'm going to make automatic street light project over there. Smart project based on LDR sensor. So you can use LDR sensor. So this one sensor I'm going to take it. So how you can use this sensor, because this sensor is a resistive type. So as I told you earlier, so you cannot use this sensor directly with the microcontroller, because microcontroller will read only voltage signal, but the sensor will provide you resistance signal. So what you can do over there, you can convert that resistance signal into a voltage signal using voltage divider rule. So I'm going to use this resistance over here, fixed resistance, and this one wire I'm going to connect with ground, and this one I'm going to connect it with 5 volt. And now I'm going to get output from this common point. So this one is my common point. So how you can get output? So I'm going to share with you output first using multimeter, so that you can visualize that how circuit is working. So negative, I'm going to connect with negative, and output I'm going to connect with over here. So let's check it out how it is working without writing code. So now you can see it, that value we are reading it in a millivolts. So as we are going to change that light intensity, my voltage is changing over here. So that is my motto, that I will change my resistance, my voltage should be changed. So the deflection in a resistance is being get converted in a voltage. That voltage we can read it in a microcontroller, and we can use some condition over there in that my value. So let's see it how you can use it. So this output I'm going to connect it with my microcontroller, so that we have used it. So that output we have taken it from over here to A0 pin. The code is same. So there is no change in the code. So code is changed. Now I'm going to start simulation. You can check it out. That value you can see that is 6. So as I'm going to change it, so that you can see it over here. As I'm going to increase light brightness, you can see it that the value is increasing, and as light intensity is decreasing, you can see value is decreasing. So my light is, as the light intensity is increasing, light is turning on, mean it's working reverse. So what you can do, you can make it low and you can make it high. So you have just reversed the condition, mean as that darkness is high, at full darkness light should be on. As sun is rising, you can see it. As sun is rising over there, you can see it. At brightness, light will get off. At full darkness, light will be get off. That is automatic state light project that you can see it over here. So at darkness, light is on. At brightness, light is off. At darkness, light is on, light is off. That you can see. So that value you can set it properly, that 500, 400, what value is required. For that you have to calibrate your value in a real time over there, in real time project or real time weather condition or environmental condition. Then after that you can calibrate it. So this one is about reading any kind of analog sensor. So now I'm going to talk about that analog output. If you want to control motor speed, that also you can do it. Earlier we have controlled that motor speed only using this LDR. Now if you want to control that motor speed using some potentiometer or automatic, that also you can do it. And if you want to control that light intensity of that particular LED or particular bulb, that also you can do it using analog output. So when we have to write analog output, for that we are going to use PWM technique. So that PWM is known as pulse width modulation. So that technique we are going to use it over here. So in a PWM, what we can do, there is a dedicated PWM pin in a digital pins that you can see it, that is 3 number, 5 number, 6 number, 9 number, 10 number, 11 number. These are PWM pin over there. So these pins we have to use it for analog output. That negative symbol over here you can see it, that is PWM signal. These pins you can use it for as a digital and as well as PWM pin. So now I'm going to use PWM pin over here. So in a PWM pin, what we can do, you can use, you can give output in the format of 8-bit. So why it is so? So let me explain you that PWM. So that is PWM technique. That is very interesting technique over here that we are going to use it. So PWM stand for pulse width modulation, means we are going to control that pulse width, and with the help of that we are going to get variable output voltage. So how PWM is working? So just take in a simple example of your ceiling fan. So there is two control knob for a ceiling fan. One is on off switch and second is that potentiometer or rotatable knob over there, regulator we can call it. So you can make your regulator at full speed, fully on, and your switch off, that fan is off. So I'm going to use one condition over here to explain that PWM technique. So as I'm going to turn on my switch, my fan will start getting on, and I'm going to off it after 10 seconds. Mean I'm going to repeat one cycle, mean 10 second on, 10 second off, 10 second on that switch, 10 second off that switch. So on off, I'm going to repeat it for continuous 10 minutes or 5 minutes. So what output you are going to get at your fan? So you will get output over there in that fan, mean your fan will be not fully on and your fan will not be fully off. So you are going to get average speed over there at the output. Same technique that we are going to use it over here in a microcontroller when we have to give analog output. So mean we are going to make it on and off that particular digital pin for particular time. So if on time is more and off time is less, so what is happening over there, you are going to get according to that output over there, means 75% or 25%. So you can see it over here, when 50% on time, 50% off time, you are going to get output voltage that is 50% of supply voltage. So similar way over here, when 25% on time and 75% off time, you are going to get output voltage that is 25%. Similar way over here, 75% on time, 25% off time, you are going to get 75% off time. So you can visualize over here that PWM technique, how it is working. These are PWM pin. So one that 75% off time, so this one is the average output voltage. You are going to get like this. When that 50% on time, 50% off time, you are going to get average output voltage that is 2.5 volt, that is 50% of 5 volt. This one is a 75%. So off time is very less, on time is more. So similar way that technique is working. So you can use LED to control that brightness of that LED. So that I'm going to use it over here. So very important point, when we are going to write code in a microcontroller, so that analog output is working in the format of 8 bit. 8 bit mean we have to write value in the format of 0 to 255, and we are going to get output over there 0 to 5 volt. So like earlier we did it in analog read, that was 10 bit. Now we are going to write in the format of 8 bit. Mean we have to write 0 to 255. In between value we have to write it, and we are going to get output accordingly. So let's see it how you can use it. And we have to write code in the format of this analog write pin number and their value. If we are going to write 0, then we are going to get 0 volt output, and as we are going to write 255, we are going to get 5 volt at the output, and if we are going to write 128, we are going to get 2.5 volt at the output. Let's see it how you can use that PWM technique over here. So I'm going to delete this one, and I'm going to use directly PWM technique, and after that I will use potentiometer also over there. So now this one LED, I'm going to connect it on 11 number pin, because 11 number pin is PWM pin. So in this pin I'm going to write code. So this one code we have to delete it, and go to output. In output, the third block we have to use it. So third block is for PWM, only PWM pin you will find it over there. So you can select 11 number pin, and you can write value. You can write value over here from 0 to 255. At 0 you are going to get output voltage that is 0, and I'm going to use all other values also over here. After interval of 1 second, you can use 100, so that you can visualize the technique. You can use it 200, and at the end I'm going to use it 255. So after 255 I'm going to take delay of 2 seconds. So that output we are going to get in interval 0, then some voltage, then some voltage, and at the end we are going to get 5 volt. So let me use over here that multimeter to check it out, that how much output voltage we are going to get it on that particular pin. So negative you can connect with the ground, positive you can connect with the 11. For some time I'm going to remove that LED to check value on that particular multimeter. You can start simulation. So automatically my value will change from 0 to 5 volt, that you can see it, 0 to 5 volt. So my value changing in a step 0, 1.9, 3.91 and 5 volt. But we have written value over here in the format of 0, 100, 200 and 255. Now 0, this one is 100 value, this one is 200. So this one is moving faster, so I can take delay of 2 seconds. Every step I'm going to take delay of 2 seconds. Now you can see 0, then 100 value you get 1.9, then at 200 you are going to get 3.93, and 255 5 volt. And this one will repeat for infinite time. So you will get average output voltage over there, whatever is required. So now I'm going to use LED over there to control my brightness. So you can use resistance also with the LED. Otherwise you will not able to see proper brightness. So that same pin, 11 number pin, we have used it with the LED. Now you can see it, output voltage. So that output voltage will get dropped due to that LED. So you will not get proper 5 volt, but you will get output over there. So I'm going to delete it. Now you can see that voltage will get, in the brightness of LED will change 0 to maximum, like step by step, that you can see. I think you are able to see that the brightness is changing. In 3 step it is changing. So that you can see it. So if you want to say check more proper brightness, so you can set that value over there, 150. That is exact value of resistance. Now you can see it. Yes, brightness is changing. So that you can see it. If you are going to use motor over there, then you can control that motor speed. So I'm going to use motor. So these basic things are essential. The sensor interfacing are essential for making any kind of smart product based on IoT. So I'm going to use 11 number pin. Start simulation. That output, you can see motor RPM is changing in a interval. This one is full RPM 0, then RPM 200, 2000, then 4000, and then 5000. So that you can do it. And all these values you can see on the scope also. So scope also you can find it over there and you can use it. So this scope I'm going to use it. So ground I'm going to connect with the ground. That output pin I'm going to connect with 11 number pin. So let's see it how that scope is working. So you can start simulation. So scope adjustment I'm doing it 1000 microsecond. Now you can see it. That 0 at some value you can see that on and off time. Over here on time is more, off time is less, and this one is 5 volt. 0, then this multimeter I have not connected, so let me, if you want to connect that also you can connect it, or you can delete it also. So now you can see it, what is happening over there. At this RPM you are going to get this volt, at this voltage you are going to get these PWM, pulse width. So you can see it, this one is 0, this one is approximate 25%, this one is 75%, and this one is 100%. So again 0, at this one you can see RPM also changing accordingly, and pulse width also you can visualize it. You can see on time is more, off time is less, and that is changing. Now fully on, then 0, then on time is less, off time is more, then again on time is more, off time is less. So that output is changing accordingly. So that you can use it, digital input, digital output. We have discussed over here analog input, analog output. We have discussed digital input and digital output. We have discussed, and many projects also we have discussed simultaneously with the application of the sensor and their uses. So that you can do it. So after that we are going to discuss about cloud, that how you can send data to the cloud, and how you can control your home appliance, and how you can put some AI analytics on the cloud. That we are going to do in a tomorrow session. So over there also we are going to use one into another tools, and with the help of that we are going to send data on the cloud. And I will show you a few hardware also, that how you can send data from the hardware. That also I will show you. So now I'm coming back to question answer. If you're having any kind of queries, any kind of doubt, that you can ask it. Meanwhile, if you want to know more detail about these sensor interfacing, so I will share with you my YouTube channel. Over there you will find all the detailed tutorial of all these things, that how you can interface it. So that link I will share with you. So over there you can find all the thing about Tinkercad, their usabilities, and over there in these tutorials you will find in detail that how you can use different sensors. In the videos, or you will find all the detail about sensors, LDR interfacing, and coding and all that. So that link I will share with you. Yes, now if you're having any kind of queries, that you can type in the chat box. So that video link I have shared with you. Yes. Yes, now you can type your queries, or you can ask your queries over here.
Participants, if you have any queries, you can post it in the chat box, or you can just unmute your mic and you can ask your questions.
Yes, it is open source. So whatever we have discussed, that is fully open source. No need to pay anything over there, and you can use it freely.
Any other questions from participant side?
So I'm just sharing my contact detail also. If you are facing further any difficulties, so then you can contact me also over there. So I will post my contact details over here. Yes, these are my contact details. So you can contact me on WhatsApp, or via email, or on Facebook, or Instagram, and as well as Twitter also.
So thank you very much, Ajay sir. As usual, your session was very interesting and excellent, and we can see very good positive feedbacks coming in the chat box. We are looking forward for the next session going to happen tomorrow. Thank you very much for joining with us, sir.
Thank you, sir. Thank you so much.
I'm honored and lucky to have the opportunity to give a vote of thanks. I particularly like to thank our chief guest, Mr. Ajay Kumar Godara sir for his extraordinary presentation. Thank you so much, sir. I would like to thank all those organizing staff members and I thank all our participants for making this session wonderful. Thank you so much.
So participants, thank you very much for joining with us. And the afternoon session will be starting by 2 o'clock. Kindly join as early as possible. Thank you very much. And the feedback session, feedback link